is a mathematical object, word or symbol used for counting and measurement. Natural numbers. The counting numbers are called natural numbers. This collection is denoted by the letter N and is represented like this. These are some natural numbers on the number line. Whole numbers. All natural numbers together with the number 0 form the collection of whole numbers. This collection is denoted by the letter W and is represented like this. These are some whole numbers on the number line. Integers. All natural numbers, 0 and negative, of natural numbers form a collection of all integers. This collection is denoted by the letter Z and is represented like this. These are some integers on the number line. Rational numbers. A number of the form P upon Q, where P and Q are integers, and Q is not equal to 0, is called a rational number. P is called the numerator, and Q is called the denominator. For example, 1 upon 5, 3 upon 2, etc. are all rational numbers. However, we do not include numbers like 4 upon 0 or 7 upon 0, etc., where 0 is the denominator. Such extended numbers are called the system of rational numbers. As another example, 5 upon 6 is a rational number, in which 5 is the numerator and 6 is the denominator. Thus, rational number is a number of the form P upon Q, where P and Q are integers, and Q is not equal to 0. Equivalent rational numbers. Let P upon Q be a rational number, and M be any integer except 0 and 1. Then P upon Q is equal to P times M upon Q times M. For example, 5 upon 7 is same as 5 times 2 upon 7 times 2. That is 10 upon 14. So, 5 upon 7 and 10 upon 14 are equivalent rational numbers. In a similar manner, 2 upon 5 is equal to 4 upon 10 is equal to 6 upon 15 is equal to 8 upon 20. Such numbers are called equivalent rational numbers. Positive and negative rational numbers. If A and B are positive integers, then the rational numbers A upon B and minus A upon minus B are both positive, and the rational numbers minus A upon B and A upon minus B are both negative. Thus, 3 upon 7 minus 11 upon minus 5 are positive rational numbers, and minus 3 upon 5, 17 upon minus 9 are negative rational numbers. Standard form of a rational number. A rational number, P upon Q, is said to be in the standard form if Q is positive, and the integers P and Q have no common divisor other than 1. The HCF of 24 and 72 is 24. Dividing the numerator and denominator of 24 upon 72 by 24, we get 24 upon 72 is equivalent to 1 upon 3. absolute value of a rational number. We are familiar with the absolute value of an integer. Absolute value is denoted by the symbol shown here. Absolute value of a positive number, that is, integer, remains the same. For example, the absolute value of 3 upon 5 is equal to 3 upon 5. Absolute value of a negative integer is always positive. For example, absolute value of -1 upon 5 is equal to 1 upon 5. Absolute value of 0 is 0 itself. Thus, for any rational number x, we write modulus of x is equal to x. If x is greater than or equal to 0, is negative of x, if x is strictly less than 0. Rational numbers on a number line. Like integers, we can represent all rational numbers on the number line. All positive rational numbers are represented on the right side of 0, and all negative rational numbers are represented on the left side of 0. Consider the rational number 1 upon 2. Note that 1 upon 2 is a positive rational number. Thus, it must be placed on the right side of 0. Also, since 1 upon 2 is smaller than 1, so 1 upon 2 lies in the open interval 0 to 1. We can see that 1 upon 2 divides the interval into half. Thus, it exists at the midpoint of the open interval 0 to 1.
To find the rational number between two rational numbers, let the two rational numbers be a and b. So, the first rational number between a and b is a plus b divided by 2. The second rational number between a and a plus b divided by 2 is a plus half of a plus b divided by 2. Similarly, we can find another rational number between a and b. In this example, we will find the rational number between 1 and 2. Solution: rational number between 1 and 2 is 3 upon 2. Comparison of two rational numbers. There are two cases which can arise in the comparison of two rational numbers. Case 1. When the denominator are same. In this case, that rational number is greater than the other which has greater numerator. For example, if p upon q and r upon q are two rational numbers and p is greater than r, then p upon q is greater than r upon q. Case 2. When denominators are different, in this case, first we find the LCM of the two denominators, then compare the numerators of the two rational numbers. The number with greater numerator is greater. Here is an example. We need to compare 2 by 3 and 4 by 5. As the LCM of 3 and 5 is 15, we multiply 2 by 3 by 5. We get 10 by 15, and 4 by 5 by 3, we get 12 by 15. Now, as 12 is greater than 10, so we have 4 by 5 is greater than 2 by 3.